Welcome you all. Today we are going to discuss one more problem in a tire characteristics. Estimate and plot cornering force, aligning torque and braking effort of a car tire at the normal loads of 2, 4, 6 and 8 kilonewton with the slip angle from minus 20 degree to plus 20 degree and a skid of minus 20% to plus 20%. The values of the empirical coefficient in the magic formula for a tire are given in table. They given that vertical load Fz is 2, 4, 6 and 8 kilonewton and use the tire magic formula and the coefficients are given in table. Estimate the cornering force Fy, aligning torque Mz, braking effort Fx. This is in Newton, this is in Newton meter, this is in Newton. Now, they're given 4 loads. Each one load we have to find out these things with slip angle for this cornering force aligning torque are minus 20 degree to plus 20 degree and the skid of tire minus 20% to minus 20% to plus 20%. Now this problem they are asking 3 output with 4 loads and the slip angle and the skid are varied from minus 20 to plus 20, that is 9 variables. So we have to make this one by program. First we have to identify what is this magic formula. This figure shows tire magic formula where this point is the origin 0, 0 and this origin is shifted as vertical shift from this SV and horizontal shift HH, and then in the magic formula the cornering force, aligning torque and braking effort can be found from single formula. Fym is at Fx, that is equal to capital Y of x is equal to small y of x plus SV. This SV is the vertical shift. Then this small y of x is equal to d sine c r tan of bx minus e bx minus r tan of bx, where this b is the stiffness factor, c is the shape factor and d is the peak factor and e is the curvature factor. This x is a variable that can be identified from the formula, that is small x equal to capital X plus sh. This capital X is the slip angle or skid. Then SH is the horizontal shift. Now take this one as equation 1, equation 2, equation 3. So in our case, these 3 equations, that is the coefficients of the tire magic formula are given in table for 4 loads, that is cornering force, aligning torque and braking effort. For each load the coefficients has different values. Now we have to find out cornering force, aligning torque, braking effort for 4 loads 2, 4, 6, 8 kilonewton with minus 20 to plus 20 slip angle in degree and skid in percentage. This is 9 variables. This one is 4 and this one is 3. So we have to find out 3 into 4 into 9, 108 output or 108 results. This should be carried out by programming language. Either you can use C or C++ or MATLAB or Visual Code or Python, etc. Now in this class I will explain how to use this algorithm. This is the graphical flow chart of the programming to solve this given problem. Now here the input is 4 loads 2, 4, 6, 8 kilonewton. Then based upon this load we have to find out the horizontal shift, vertical shift, stiffness factor, shape factor, peak factor and curvature factors. These 3 things for this cornering force, aligning torque and braking effort as you keep it as array. Then this horizontal shift added with the what is the slip angle or skid, it will be giving a variable x, slip angle or skid. Then the stiffness factor, shape factor, peak factor, curvature factors processed with variable x in the formula d sine c r tan of bx minus e into bx minus r tan of bx. We can get this small y. This small y added with SV, vertical shift, we can get capital Y. Capital Y is the output. It will give the output as cornering force, aligning torque and braking effort. Then after processing this as input, the coefficient keep in array, and the given slip angle or skid also as input, then we can find out the capital Y. When you are making a programming, the output of the results in a tabular form is given here. After this results, when you are making a plotting, we can get the output cornering force versus slip angle in degree. Here this one is 2 kilonewton, 4 kilonewton, 6 kilonewton, 8 kilonewton, and this one is aligning torque with the slip angle. Here is 2 kilonewton, 4 kilonewton, 6 kilonewton, 8 kilonewton. This one is braking effort versus slip angle, 2 kilonewton, 4 kilonewton, 6 kilonewton, 8 kilonewton. So output of these three, cornering force, aligning torque, braking effort, we can be taken as a reference. From this output, that is cornering force, aligning torque and braking effort with respect to slip angle or skid, the output curves we can take as discussed in the previous classes in aerodynamics. Thank you.
Subscribe to our channel, like if you're satisfied, and share because it may useful to someone.